Hi, I'm Elizabeth, and this is Physics 2211, Lab 1, Constant Velocity. So today we're going to go over the introduction of the physics principles used in this lab. We're going to use the analysis of the cart using the program Tracker, then the construction of the computational model using FlowScript via Python, and the observed versus predictive graph using the Tracker data and the computational model data, and then ask the questions, what if and what does it mean? So, to introduce the physics principle, the main one that we used in this lab was Newton's second law. An object in motion will stay in motion, and an object at rest will stay at rest until an outside force acts upon it. This is also known as the momentum principle, which is mass times change of velocity equals F net change in time. You can see in the first photo, my model of the force diagram, which Fg is the force of gravity and Fn is the force normal, which is the force of the table holding up the cart used in the experiment. And as you can see in my diagram, those two are equal to each other. Therefore, force net is zero, therefore acceleration is zero, and therefore velocity is constant. Since velocity was constant, I was allowed to use the constant velocity equation, or the definition of velocity, which is velocity equals change in distance over time. And you can see in that second photo where I used it to calculate the final velocity. So you can see the in position for my experiment minus the initial position over the time. And you can see that I get the velocity of the experiment, which is 0.301852861 meters per second. So here's the video from Tracker of me tracking the cart. And as you can see, it has all of the data points from the tracking along with the meter stick, which I used to calibrate, and the XY to make sure that everything was even and correct for the most part. So here starts the computational model. I didn't change the mass of the ball since when velocity is constant, mass doesn't really affect the constant velocity. I did, however, change the initial position vector and the velocity vector. So the initial position from the experiment was not 0, 0, 0. It was negative 0.041900, and this did affect things. So I did make sure that in the computational model that it starts from the same place. And then the velocity vector uses the velocity found in the previous slide. And we're only really checking the velocity in the x direction because the velocity in the y and the z direction didn't really affect the cart. And then the change in time was used for the timestamps from the video of the cart, which was 0.033. Here's just the continuation of the computation. Since it took 1.835 seconds for the cart to move across the video, that's what I used for the time for the computational model. And of course, Fnet vector is 0, 0, 0, because Fnet is 0 in this equation, in this experiment. And then you can see the momentum principle here being used to develop the graph and like the data points through the computation. And then to advance the clock, the timestamps are based off the experimental timestamps. So here you can see the position time graph. The blue line is the theoretical and the red line is the experimental. They are pretty even at the beginning and end, but you can see sort of towards the middle where they separate. This is due to a couple different things, and you can also see where it does not start at 0, 0 right there, and position was in meter and time was in seconds. So the reason why that those lines are not completely even, one possibility is tracking mistakes. The camera was not completely level for the whole thing, and so that might have caused some errors. Two, the cart was not rolling completely straight. It kind of hit the meter stick and then went straight. And secondly, since it was rolling, there does have to be a little bit of friction there for it to roll. And so that friction could have slowed down, could have caused the cart to slow down, which causes that error. Now, what does this mean? So as you can see in just the force diagram, once again, the force of the objects, the force acting on the objects is force of gravity and force normal. And since they equal each other, force net is 0, which proves the constant velocities shown in the experiment and the theoretical. And secondly, if the axes were flipped, that would just mean the velocity would be the same number but negative. So it would be negative 0.301 instead of positive 0.301. It would also cause the position time graph to be sloping downwards in the negative position. Thank you.